Hello and welcome to an all-new episode of the Bitcoin News Show right here on the CryptoCast Network. Thank you, ladies and gentlemen, again so much for joining us on this beautiful Sunday or whenever you're joining us. So if you missed the live show, make sure to join us in the comments below. We are screen sharing our website, the CryptoCast.network website, where you can find our YouTube, Twitter, Instagram, iTunes, and RSS feeds. We also have some merch if you guys want to check that out. And then if you will really want to support this channel and content like this, we definitely ask that you take a look at our donation address there on the website at CryptoCast.network, as this is a community-supported YouTube channel. So we very much thank you guys for all your donations and all your feedback. We just try to bring the Bitcoin truth to you guys as much as we can. So with that aside, let's stop the screen sharing and get into the quick bit section before we go ahead and get to our main three topics, guys. Let's see if we can find the notes. It's around here somewhere. There we go. Okay, here we go. So the quick bit section, guys. The crypto exchanges out there, be careful, everybody, as usual, but the crypto exchanges out there are still complete amateur hour, guys. We have some people on Kraken that flash crash that thing down to $100 if you guys didn't catch that. So make sure you guys are very, very careful if you are day trading on these crypto exchanges. They are simply not up to snuff yet, but I expect this to change going over the next few years, 3 to 5 years specifically. People are going to start complaining about this more and more. Then we got Samourai Wallet releases their public open source code of their Dojo software. So this is really cool. Up until now, of course, you've had to need to trust the Samourai servers, but now with your public keys, but now you can run your own server instead. So make sure you guys check that out. Samourai Wallet still doing awesome privacy stuff, awesome privacy work for Bitcoin. Make sure you guys check them out. Then BCH, everybody loves them. The BCH chain suffered a 51% reorg just recently, where some transactions were reversed due to some miners colluding with each other to reverse a transaction. Make sure you guys check that out. BitMEX did a pretty good write-up on that, as they usually do. The BitMEX research team over there, guys. Make sure you check that blog out, blog.bitmex.com. And then we got the Human Rights Foundation that have published a guide for activists and journalists to use Bitcoin privately. So this is really, really cool. This is important, guys, because Bitcoin is not very simple to use, and to use it privately, it's even more difficult. So articles like this really, really help the people that need it the most, that need the privacy on the Bitcoin blockchain the most. So check that article out by the Human Rights Foundation. And then Hodl, the non-custodial exchange over there in Latvia, they have enabled mainnet trading via Lightning Network, and I expect this trend to continue. More and more exchanges enabling Lightning Network activity wallets or Lightning Network wallets, so that you can at the very least be able to exit out of the exchange via Lightning. So that maybe if you don't want to do trading with the trades in and out with Lightning, but at least be able to withdraw your funds over the Lightning Network. So that's going to be really cool. I expect that trend again to continue. More and more exchanges supporting Lightning Network. Then we have the Bitcoin symbol has been introduced into Apple and Microsoft platforms. So it is a sign of the times, guys. Bitcoin becoming more and more mainstream. We have now officially have the symbol in our desktop application software, our Office software. So make sure to check that out. That's pretty funny. Then we got LND watchtowers, guys. They're almost here. I believe a pull request was recently created. So this is getting us really, really closer. Watchtowers are going to be very important for those wallets that are non-custodial. So if you guys don't have a custodial wallet and you're taking care of your own, running your own Lightning Network node and taking care of your own transactions there, this is going to be really important to have. So make sure you guys check that out. Again, article from Bitcoin Magazine. Those guys continue to kill it. A shout out to Bitcoin Magazine. And then Ledger integrates Native Segwit BEC32 support. This is really cool. BEC32 has a number of features over the standard transaction. So guys, make sure you check that out. More and more people are supporting that as well. And finally, Tippin, the Lightning Network Tippin bot over there for social networks like Twitter has released a version 1.0. So those guys continue to keep killing it over there, keep supporting new features. So if you guys want to really test out the Lightning Network, a Tippin.me wallet is a great way to do that. They are, I believe, custodial right now, but I think they are having options to run it non-custodial as well coming soon. So with that aside, guys, let's go ahead and introduce our amazing panelists. We're going to have a tech show today, guys. We'll be talking about some of the latest tech in Bitcoin. So I'm really excited about this. Of course, it's near and dear to my heart. So let's introduce some of these guests. We have Mr. Patrick Miller, returning guest here, guys. He's a Bitcoin enthusiast and pundit. Patrick, how you doing?
I'm doing great. Good to be here. Thanks so much for having me again.
You bet, man. Thanks to have you on again. We've had Patrick on a number of episodes. Make sure you guys check that out. And then we got returning again, Mr. Gabriel Devine, again, Bitcoin enthusiast, entrepreneur, and to date has never been served a gag order. Gabriel Devine, how are you, man?
I can't actually tell you right now, and I've taken off the warrant canary from my website after a visit from some men in black. No, I actually have not I have not. I can speak totally freely. I have been approached to promote scams a few times on Twitter. It was always very entertaining to read their pitches in my direct messages. So please keep sending them. They are hilarious.
Come on, Gabriel. We got the best profitable ICO for you. All right. And finally, guys, introducing the special guest today, joining us on the last minute. So we really extra appreciate it, Mr. Jameson Lopp. You guys all know him, Cypherpunk and CTO of Casa Hodl. Jameson, how you doing?
Not bad. Glad I could join you today.
Yeah, man, really appreciate that last minute request. Of course, Elena was supposed to be on, but she couldn't make it due to some scheduling conflicts. So we're more than happy to have you as well, Jameson. So thanks so much, man. Let's go ahead and get right to it, guys. We got our three main topics. It's going to get a little technical, but we do want to try to explain the main points of these technologies to try to get across the pluses and minuses. So let's go with you, Jameson, first. The first topic we have here, guys, is the Bitcoin developers propose stronger, faster blockchain network via Erlay. So this is a new protocol spelled E-R-L-A-Y, created by Gregory Maxwell and Peter Woolley. It alters the way these transactions are relayed so that they use significantly less bandwidth. Jameson, let me ask you, could this be considered maybe a bit of a game changer for the Bitcoin network, because we are talking possibly about bandwidth speeds increases of 75%? What is your take on this?
Yeah, so I mean, that's one of the most, I think, prevalent improvements that we've seen in the Bitcoin protocol over the past few years is efficiency improvements, performance improvements, trying to continue to decrease the cost of running a fully validating node. And I can tell you personally from the nodes that I run, you can even go look at the stats on satoshi.info. Bandwidth is by far one of the biggest bottlenecks, especially if you're running a node that is highly connected. So my node, for example, maxes out all like 125 peers or so. And if you actually drill down on the bandwidth page, you can specifically see what the different protocol messages are that are using the different amounts of bandwidth. And surprisingly, one of the highest uses of bandwidth is the INV message. And if you're not familiar with the low-level protocol, INV basically means invitation. And it basically means you are asking another node, or another node is asking you, hey, do you have this piece of data? Do you have this transaction? Do you have this block? So this is not actually being used to transmit the blocks and the transactions, but rather as a part of almost like a SYN ACK type of back and forth handshake of saying, hey, do you want this information in the first place? And just due to the way that the data propagates on the network right now, it is incredibly redundant. And I'm probably just pulling this out of thin air, but if, for example, you're connected to 100 peers, I bet that you receive INV messages more than 50 times for every transaction and block that comes through you, because many of your different peers are going to be sending you these messages, and then you're going to be sending to the other peers basically as the transaction or the block floods out through the entire network. There's really no sophisticated logic to it. It's a spray and pray to everybody, which means it's very massively redundant and robust. You're very likely to get your message out to the entire network very quickly, but you're also going to be sending a lot of redundant back and forth to your peers. So this improvement is basically changing it so that you're only going to be directly talking to a subset of your peers, and then there's going to be a reconciliation phase later just to make sure that you didn't miss anybody.
That's really cool. I like the reconciliation phase later. So just to quickly recap, guys, make sure you do check out statoshi.info. This is Jameson's site where he posts a lot of stats about the Bitcoin blockchain, including some of this data here that he's saying. And the spray and pray, I like that description more than the flood network. Spray and pray. Essentially, that's what these nodes do, which has downsides and upsides, of course. But one of the downsides is the redundancy. So essentially, the main idea then is, instead of announcing every transaction to every peer, announcements are only sent directly over a small number of connections. So that's going to be interesting. And apparently they say that if outbound peer count was increased to 32, Erlay would save around 75% of the bandwidth. So that is really interesting because, guys, one of the most important things we can do for the Bitcoin protocol is to make sure that everybody can still run a full node. So that is very, very important to be able to validate your own transactions. That is one of the main use cases and value propositions of the Bitcoin blockchain. So, Gabriel, let's go to you. What are your thoughts on Jameson's comments and this new protocol, this called Erlay? The ability to have faster block propagation. How important do you think this is to the Bitcoin network in the future, and how likely do you think this is of getting soft forked in?
I just love this type of low-level research and development, and of course, innovation and massive increases in efficiency, and without too bad of trade-offs, just because it's a better invention. Replacing little chunks of the code that were there as like, well, we can, Gossip Protocol, just slap it together, it'll work. We've only got 6 users. It's 2009, 10, whatever. It's just like popping it together and just make a couple of small improvements over time. And then in 2011, I'm sure people were like, okay, there's quite a few of these INV messages. Probably I'm sure people were already noticing back then, and someday this is going to be an issue, and maybe we should try to come up with something better. And that's probably what Greg Maxwell and Peter Willey were doing when they came up with Mini Sketch, which is a hardcore mathematical invention that they made public. I believe it was about 2 years ago, and that's for the set reconciliation, because you need to instead of sending messages to everybody and just flooding and going, hey, let's hope it works, you're talking about dividing it up into chunks, and that always introduces risks unless you're really careful with the mathematics and check everything to make sure that it's provably not scammable and all that. And so they had to invent Mini Sketch first before they were even able to put together this transaction relay protocol, Erlay, which I guess is maybe kind of named after efficient relay. I'm not sure. The other names of innovations that we're going to be talking about today, I have my notes here in my special book, have much more clever names. Erlay is a little bit clunky, but you know what? It's short, which is great. So it works. And I'm not here to critique the aesthetics here. The point is that this thing exists. It's not just Greg Maxwell and Peter Willey. It's also Gleb Naumenko and his advisors at UBC, which are Alexandra Fedorova and Ivan Beshasnich. So these 5 amazing, people put together this incredible set reconciliation thing. It's mathematically, pretty intense. It's a little above my head, but I know that, this is how these protocols work. It's totally incredible. Actually, all of the subject matter that you picked today is like totally mind-blowing, Vortex. I knew that this stuff was coming out because I've been reading this stuff, but like these 3 things are totally amazing. And Erlay is just such a great example of the type of really essential building block, low-level work that guys like Willey and Maxwell have been doing for several years now, that are just things that the users will you just won't see it, and everything will just work a little bit better and a little bit more efficiency. And it's like this stuff that we're obviously working on UX stuff too, and Lightning and stuff that's really like more on the user end, where you can kind of notice it more as a layperson. But this is the stuff that we really need to take care of now, because after 2 years ago, when transaction malleability, the largest bug in Bitcoin, was fixed, now we have all these efficiency issues that aren't bugs; they're just inefficiencies that the core developers are rightfully very focused on, because it's conceivable that as time goes on, the protocol, the Bitcoin protocol itself, will begin to what you call gel or congeal a bit and become more resistant to changes that are at the low level. Whereas now people are real open to it, and especially when you have a situation where Mini Sketch is an efficient library for set reconciliation. It's a mathematically provable situation. Now, of course, sometimes people overlook things, and there's vulnerabilities that you didn't foresee. But in general, if you can, mathematically prove things, and that's a theme through actually all 3 of these subject that you chose today that are totally amazing. So really fantastic situation where basically the efficiency is increased by 75% with no trade-off, just because it's a superior design.
I would mention there is one small trade-off. This is not a 100% perfect solution, and the trade-off is, I think they estimated it would take 1 to 2 seconds longer for a transaction to propagate across the entire network. So the trade-off is a very, very slightly slower propagation across the network for a very huge efficiency gain in the total amount of bandwidth used across the network.
Do you have, off the top of your head, I know that you know, with Satoshi, you deal with the stats a lot. Do you have any idea what the average transaction propagation time is lately?
Yeah, actually, if you look on bitnodes.earn.com, they have a stats page with block and transaction rate, and I think that it's only in the realm of 2 or 3 seconds.
Okay, so that's actually pretty big percentage-wise. That's actually a pretty nasty knock. That's like a 20, 30, 50, even up to 50% slam on the propagation time. So that's a moderately large trade-off.
Well, so they had several graphs in the actual paper that was released, and of course they had simulated various sizes of networks. So there were a few assumptions at play, but I don't think that it'll slow down the propagation by more than a few seconds, which you know, we're mainly discussing, you know, what is really going to impact the user here. And I think that from an end user impact, they'll see a lot more positive impact by the bandwidth reduction than they will from having to wait a couple seconds on a transaction propagating.
Yeah, that's clear to me too.
Yep, it's all about trade-offs, guys. You know, this is what the Bitcoin Core developers and developers working on Bitcoin are just live to do. They just live to create, you know, more efficiency and find more efficiency. And when we find even just 5 to 10% gains, just everybody kind of on the mailing list pretty much jumps up and down. But you know, when you can find 75% gain, guys, that's pretty impressive, especially when we're this far into the protocol development. Patrick, let's get your comments in here before we end this topic. Go ahead.
If I may, I just want to quickly wrap up what I was going to say.
Oh, sure. Sorry. Go ahead,
for you guys out there, just to give you an idea where this is at. The white paper is out, and they're you know, soliciting feedback on it. And once people begin to, you know, gather toward consensus on Erlay, they will be creating a BIP, because I'm assuming that they're actually, Jameson, if you could comment on what's required. What would be required, the type of thing that will be required in the BIP, because this is something that requires changes, obviously, to the Bitcoin Core protocol.
Well,
so
I mean,
some sort of change needed.
Change. It's just a you know, a data and networking relay change. So I imagine it's not going to be that difficult. I don't, you know, it would be speculative to say, like, how are we going to implement, you know, like a handshake, I guess, of like, how do we know which peers we can do this set reconciliation with? Does it have to be a bidirectional thing? I'm not entirely sure what level of like compatibility it will have with nodes that aren't performing that. But it's definitely not a consensus change. So I think that it should be fairly simple to spec out and get consensus on implementing.
Very interesting indeed. All right, Patrick, let's get your comments in here before we end this topic. Go ahead.
Yeah, I read the paper as soon as it came out. It was really exciting. The propagation time trade-offs that were made there, they did mention in the paper that can be adjusted. So if there was, you know, they decided to maybe reduce those propagation times a little bit more, there could make a trade-off for a little bit more bandwidth usage for a little faster propagation times. But in the paper, they mentioned they specifically chose that because they seemed that was like the right trade-off. I don't have much more to add from what these guys did. I just think this is the important work that needs to be done in order for the Bitcoin network to really scale. So even, you know, if, you know, as let's say blocks continue to grow in size and, you know, there's more bandwidth pressures on nodes, there's more transactions, this is the exact type of innovation we would want in place if there was ever going to be further growth in the block size and more on-chain transactions, and also which I'm not sure if that's going to happen. But also this is, you know, this just reducing this bandwidth is really important for allowing full nodes to operate on really small devices. And that's the key point here, is that this is kind of a game changer for, you know, very like mobile devices or very low power, low, IoT type devices and stuff like that will benefit strongly from this.
Yep, great points, Patrick. I mean, again, what everybody has said here is that this is the low level, guys, iterative work that really results in orders of magnitude efficiency over time. This is just the really important work, the stuff that's not sexy, that we can't just place on a on a big conference or anything like that. But just one final point I wanted to add is that, remember, all of this, guys, is happening simultaneously, right? So we have amazing improvements like this, to block propagation bandwidth, and then we have people working on the financialization of Bitcoin, and then we have people working on UX, right? Some of the improving wallets and things like that. So this, just all of this stuff, guys, is happening because Bitcoin is actually a truly decentralized, the only decentralized blockchain at scale in production, in my opinion. So it's very exciting to see all this stuff happening. And again, guys, Bitcoin is scaling. We have faster block propagation than ever. We have blocks consistently over 1 megabyte, and we have more and more work being done on the Lightning Network. So very, very cool stuff, guys. Let's go ahead and move on to the next topic here. Before we do that, we would ask that you could just please, if you guys are new to the channel, hit that subscribe button, and otherwise hit the thumbs up. Really helps us get into more people's feeds. And if you are listening on the audio, we really would appreciate a review on the iTunes, as again, that helps more people find the show. So thanks again, guys, for joining us. Let's go ahead and move on to the second topic here. Hyperloop, more technology coming out of LND over there. The technology, or the company being run by Elizabeth Stark, is actually invested in by the Twitter CEO Jack Dorsey. So it's one of my favorite companies because of that. So interesting stuff, guys. Hyperloop, a new concept by Lightning, or by LND Labs, aiming to solve liquidity problems. So this is pretty cool because they did release some of this technology earlier called Loop In. They released it about a couple of months ago, and of course we covered it here on the channel. This service allows users to fill or empty Lightning channels without closing them, thus reducing on-chain fees. So it really helps manage your liquidity. And so Jameson, again, let's go with you first here on this. This Hyperloop concept, it does rely on something like signature aggregation, and so maybe it would work even better with Schnorr and that type of things. But what is your thoughts on this technology? And again, like, how difficult is this going to really to be used on the network? Any soft forks or any crazy things like that we need that we need to get this working?
I mean, from a technical standpoint, it's already usable. I mean, it's basically using a technology called atomic swaps, and more specifically, it's using something called submarine swaps, which Alex Bosworth and Rose Beef both kind of came up with independently. And this is really just another method for using quote unquote hash time lock contracts, which is one of the fundamental features that is used for Lightning Network channels. But instead of just creating a Lightning Network channel, instead you have two different people who are interacting with a middleman. Now, this middleman is not a trusted custodian, but rather the middleman is kind of the one who is helping bridge the liquidity gap. And so you've got one person who has on-chain funds and wants off-chain funds. You've got another person who has the opposite. They have off-chain funds in a Lightning channel, but they want on-chain funds. And the middleman is basically the one bridging the gap where
that's the swap, right? That's why they call it swap.
This is the swap, though. You can do traditional on-chain atomic swaps without any middleman. But essentially, the middleman here is helping provide the liquidity where they're accepting the on-chain deposit, and there's a little bit of cryptographic magic going on with regards to the Lightning Network invoice, where there's this like pre-image of some data in the invoice, such that once that invoice gets paid, they can then take possession of the on-chain deposit. So it is a trustless atomic swap, but it is going from on-chain to off-chain funds. So this gives you a new way to manage liquidity. The thing is, though, I think the bigger question is, like, how do we actually use this technology? How do we make this technology easy for someone to just like click a button and have it all happen under the hood? Because if you're requiring people to go out and like find a liquidity provider somewhere and manage the sort of peer-to-peer aspects of it, that's not going to be a very user-friendly experience. And so, they have this software that you can run that basically enables you to become a liquidity provider. I cannot speak much more to how well it works because I haven't actually tried out the software myself. So it's still mostly theoretical from my perspective.
Yeah, and this again, this is very interesting. Batching together using some technologies that we already have and ideas, concepts we already have, combining it with the Lightning Network seems to be really fascinating. I mean, batching all of these inputs together with signature aggregation, and it is a bit of a chicken and egg kind of problem that we have here with Lightning. Because and even with Bitcoin when it comes to merchants, but really with Lightning too when it comes to liquidity. It would be easier to have more people. It would be easier to get liquidity if more people were on the Lightning Network. But of course, to get more people on the Lightning Network, you need more liquidity. So it's a bit of a chicken and egg, but the thing that solves this problem every single time, guys, is simply time, right? So time and allowing more people to adopt to the system over time. So this is really interesting. What I really think that is cool about this technology is that it's kind of future proof. So it's right now it's prepared to be used with AMPs, right? Atomic multipath payments. These are essentially allow a user to receive multiple transactions as if they were one, reducing the on-chain cost of sending multiple transactions to the same party. But it's also ready to go for for future things like Schnorr to be able to improve it even more. So that is really interesting to see because remember, this is using all these previous technologies that we were talking about. Like, what is it? Let's see if I have a list of all of the ones that are have here. I had a list. There were so many in here, but of course,
I got it.
Go ahead, man. Listen, Gabriel.
Okay, well, first of all, Lightning Loop, right? So Hyperloop is a development on top of Lightning Loop. Lightning Loop was created, I believe, you was certainly using, like you said, the AMPs, atomic multipath payments, but also MuSig, which is the new multi-signature protocol that was created by Greg Maxwell, I believe, and that depends on. That serves as a building block for Taproot, and then Schnorr and Taproot are going to both make Hyperloop more efficient. So, like, I actually wanted to. Can I chime in now and
go ahead, Gabriel? You already have, man. Go ahead.
Okay, yeah, because something you said I really wanted to talk about here, and this is so important to understand for anybody into Bitcoin and anybody into software. Free open source software, FOSS as they call it. One of the things that makes it so incredibly powerful is this combinatorial aspect, where you never know what individuals are going to think of. Developers are constantly looking to improve things, make new things, and make things more efficient. And there's the idea of the layered protocols and inventions being created that are independent from one another and can be used modularly and and stacks, as they call them, software stacks. That's because protocols that are developed in layers are much easier to work with than many other structures. So over time, we've all kind of zeroed in on this approach of layered protocols with free open source software. And because nobody is, Schnorr is an example of non-FOSS whose legal entanglements finally ran out, and now free open source software projects can use it. And because it wasn't part of the open source ecosystem, everybody in the world was losing out on the huge efficiencies that this amazing invention supplies to the world. So, but everything else involved with Bitcoin is totally open source. So we're having these situations where all these examples that you found today are built on these incredible protocols. I mean, you go all the way back to simple cryptographic primitives from the ancient world, all the way up through the 19th century with Charles Babbage, who created the very first mechanical computers, and he really kind of laid out the ideas that led 100 years later in the mid 20th century to Alan Turing, who created in a white paper the idea of a quote unquote universal machine. It's today what we call a computer, which was the word they used back then for people with slide rules doing math. Now we use this for the quote unquote universal machine. And every step along the way, then we had the networking inventions through the mid 20th century. Everything's been building up. 2008, Bitcoin was invented. And now we have Lightning, from 8 years after that. And now we're building all these new things and people are not randomly coming up with stuff. I mean, yes, maybe more on the math side, they're like, hey, let's make an even more efficient cryptographic perimeter or something. That's the most abstract side. But then there's the most practical side where the UX people are like, how can we like hide this stuff so that regular people who don't understand this stuff can use it, you know, and all the way to, highly efficient things and these amazing new inventions. So I just want to point that out, that this combinatorial aspect of free open source software is possibly its most salient and powerful feature. It's by combinatorial, you have to recognize the power of exponential math, where if you have 2 things, okay, then you can make 4 combinations, right? If you have 16 things, though, you can make thousands and thousands and thousands and thousands of combinations. And that's kind of what we're seeing here with these amazing inventions. So Hyperloop's really cool. Lightning has some, as in its raw form, as well understood by Joseph Poon and Tad Strija, who invented it. They knew that there was a lot of blank spots that made the usability challenging, and that it was the raw kind of concept that needed to get out there. And there's a bunch of things like, balancing the amounts in channels, being able to receive, which we'll talk about in the next subject. There's a lot of, pain points with Lightning. But the thing is that everybody that really understands this technology, when Lightning came out, they knew that the Lightning paper is actually by far the hardest part. And filling in the gaps is actually easier. So all the naysayers who were like, it's not going to be usable, were countered by the supporters saying, hey, yeah, you're right, it's not that usable. But all these 11 weaknesses of Lightning are way easier to solve than the original hash time locked concept, contract concept that they came up with. So that's kind of what we're seeing here, is this amazing combinatorial explosion, which is the term they use in biology, of amazing inventions where, all of these incredible inventions are now being put together, and they're solving all the problems that we have in Bitcoin that are pain points for usability and efficiency and everything else.
Absolutely. I mean, again, guys, example of iterative improvements. This being able to this affecting liquidity. There's a lot of people that are like, look, Lightning will never work because we have to balance our own channels. But look, people are already writing algorithms to auto balance channels in wallets, and that's going to be a big thing as well coming down the pipe. So I try to tell people that are trying to do the math on how many transactions that Lightning can support and versus on chain with the current size to be able to figure out if Lightning can scale or not. And I try to tell people, guys, that is useless. There's going to be things that we're going to invent that is going to provide order of magnitude efficiencies. So Hyperloop, in my opinion, is one of those things where we're talking about aggregate. We could be aggregating when Schnorr's in there, thousands, tens of thousands, maybe millions of signatures, millions of these transactions of Lightning in a single transaction. Sorry, millions of these interactions in a single transaction. So this is just really, really, really important to keep an eye on, to understand that Bitcoin doesn't move like this. Okay, it freaking is like S curve type of iterative, like what Gabriel was talking about, but with these exponential increases. So this is not the last, this is not the first, and we're going to see many more of these things. So great comments so far, guys. Patrick, let's go to you finally on this topic and get your thoughts on this.
Yeah, I just want to say, so signature aggregation obviously is huge for a lot of reasons. I mean, it doesn't just affect this. It's also going to affect coin joins in the future, and then any type of batching and transaction batching. And I will say that I believe that the UX challenges here are going to be solved, and the reason I think that is because when you look at what's happening with CoinJoin right now, with like Wasabi and the Samourai Whirlpool, they are solving all the UX problems with coordinating multi-parties in these types of transactions. So I really think that these are going to be minor issues, and that there will be a UX will be developed that will be very easy for users to enter into these multi-party setups, so they can open, get channel liquidity. Those are the two main points. But I also want to say that, in my opinion, is that Lightning is already a huge game changer, even if there was no further innovations on it. I believe that as it stands right now, Lightning is incredibly functional and useful. And already, you can open large channels now, and the liquidity is there to route payments. Pretty much, I haven't really had issues for the last year routing payments personally. And with liquidity, and it's only getting better and better. Just and even though if you look on like 1ml.com and you see that like the channel liquidity the actual like public liquidity is actually, there's less now if you look at that chart. However, it's the quality, not quantity here as well. So quality is really important when it comes to channel liquidity. Yeah, so I'm just really optimistic for this feature. I think all these UX challenges will be solved in time. And yeah, naysayers are going to continue to naysay, but like you guys have pointed out, this is open source software and people are building on it, whether people like it or not. It's going to happen. So.
Patrick, what determines the quality of a Lightning channel versus obviously quantity is obvious?
Yeah, I mean, I think that Ellen Big has written quite a bit on this and done a lot of experimentation. I know that I'm sure Jameson's really interested in this because of CASA, and it's ultimately those connections, those channel connections between parties. You know, is it node uptime? You know, are the channel fee rates? You know, are the routing fees set? How are those set? How do those play into how liquidity is routed? I actually believe people should be raising their routing fees and not lowering them. I think that raising them is better because I want to see what people are willing to pay to route. I personally am happy to pay more money to route if it's going to route better. So I really believe that like Lightning is a beautiful market-based solution to liquidity and getting making the UX of making payments with Bitcoin totally solved. I mean, the instant transactions, the private transactions, all these things on Lightning are what make it really useful. I don't know why people keep thinking you can do this stuff on chain. No one's going to wait. No one's going to wait for 10, 30 minutes for a block when they can just use Lightning and they have an instant settlement. I mean, it's a no-brainer. So yeah, that's my opinions about Lightning. And I just firmly believe that all these UX problems around Hyperloop and coordinating multi-parties, I don't think it's going to be a problem at all.
Yep. Jameson, any final comments on that in response to that?
I think liquidity is going to be one of the bigger challenges. Really, I wrote about that like 3 years ago as being one of the bigger unknowns of sort of the topology of the network and how it's going to evolve over time, and what tools can we build to better understand liquidity issues and prevent certain types of liquidity attacks that I don't think have really happened yet. There's certainly some interesting things that could happen if a well-funded attacker tried to start screwing with the balance of liquidity at not just a micro level, but even a macro level, and trying to like imbalance a lot of channels to try to like split the network in various ways. So these various tools for rebalancing channels and allowing them to be more long-lived and will also make them more robust against various types of liquidity attacks that could cause routing issues on the network. So it's a really complicated problem, and I'm not aware of any similar type of problem that has ever been done before. There's certainly been plenty of networking challenges that have been addressed over the years with the internet in general, but I'm not aware of any networking with this type of liquidity issue on top of it.
Yep, absolutely, man. When protocols can have value. That is very, very interesting. Yeah, thanks a lot for that. I really appreciate it. I think we can move on to our final subject of the day, guys. Before we do that, please, again, I would ask if you are listening to the audio, please go ahead and give us a review on Apple iTunes. And if you guys are on YouTube, then definitely give us a thumbs up. And if you missed the show, make sure definitely join us in the comments below, guys. And of course, if you'd like to support content like this, if you're enjoying this, which we hope you are, of course, make sure to check out our website, cryptocast.network, where you can find our donation address. So thanks again, guys. And of course, you can always add tips in the YouTube chat there with the super chat as well. So let's go ahead and move on to our final topic. It's been a very technical show, guys, and I'm really looking forward to this topic as well. Again, I mean, Bitcoin, guys, it's technical. This is the stuff we care about. This is really, really important stuff. We don't talk too much about stable coins on this channel and STOs and LEOs and whatever else we have today. So, but this is the important stuff, guys. So, final topic today, we got Statechains. Statechains scaling idea has been released, a novel layer 2 non-custodial off-chain Bitcoin transfer protocol has been proposed, and this is pretty interesting. I want to get everybody's thoughts on this because this is another layer 2 scaling protocol, similar to Lightning as far as the layer goes. Another layer 2 scaling idea, which is facilitated by a multi-sig federation, which doesn't have never has complete control. So it is a little bit kind of like the Liquid sidechain federation there, but it is interoperable with the Lightning Network. So it does allow the opening, rebalancing, closing of channels to occur off chain. In these state chains, and it can actually even make a Lightning instant, Lightning onboarding instant. So let's go to Gabriel first on this to change it up here. Gabriel, what are your thoughts on this particular idea of state chains? Is this a real scaling solution, and how is this different or better than sidechains?
Well, going back to the aesthetics of it, I forgot to mention what a great name Hyperloop is. Of course, it's they're making a joke about their Elon Musk train thing, underground to like vacuum train thing. Of course, it's built on Lightning Loop, and the idea of the loop was that they wanted to make sure the inbound and outbound liquidity were able to be balanced. So you had to create a loop there where they could kind of talk to each other, and then they're like making it more, fleshing it out more. So of course it's a Hyperloop, which is very cute. Coming back to the state chains, I like anything chain is kind of like a fun word, that obviously blockchain, but state chains is really, I like that. I like state because like you're doing something with the state. I don't know. I like that name for some reason. But yeah, this is an interesting proposal from Ruben Somson. I'm a little bit familiar with his work because he's been presenting and stuff for over a year. But it's different from Lightning. So this really plays into the centralized to decentralized spectrum, which Bitcoin. Well, the internet itself really planted a flag. Where TCP/IP is very decentralized. Obviously, the World Wide Web is something we would describe as sort of middle ground between like a private corporation and the internet itself, where the web is like a semi. It's relatively centralized. It's got a little bit of a sort of federation aspect to it, maybe not in the center between centralized. The web is pretty, as far as domain registration and stuff, it's pretty centralized. The domain registries and everything, possibly getting less. And certainly in the future, we'll have ways to decentralize it more. Bitcoin, very decentralized, you could say close to as decentralized as the internet and TCP/IP, which is fantastic. I mean, that was, there's really hardly anything else out there between, 68 and 2008 that was like as decentralized of a system as Bitcoin and the internet. And then Lightning, really quite decentralized. There's some sort of risks of a little bit of centralization, possibly with hubs or possibly with node creation and routing and stuff. But it's very decentralized, and that was one of the reasons why we were all so excited about it when the white paper came out 3 years ago. And then we have Liquid, which came out. Blockstream Corporation created it. It's a federation. It's pretty centralized, but yet it is definitely a bit less centralized than many other solutions, and has a lot of safeguards built into it. And so once again, we're exploring that middle ground that hardly had anything in it just before the last few years. And that's what Statechains is. It's something kind of in the middle, which is, once again, exploring new territory in the sort of decentralized, centralized spectrum. It's not really possible to quantify a lot of those aspects, but this is a general sort of conversation, ambiguously speaking, this is kind of, a little bit more centralized than Lightning. So people might have issues with it because it's got a little bit more trust. There's possibly more risks of people trying to rip you off, but it does have safeguards, and they're obviously very aware of the safeguards and working to, put as many safeguards in as they can to prevent problems with the transfers that happen between the entities. The centralization is the state chain entity. It's kind of like a federation, and then there's the users that kind of communicate with it. This is an amazing, once again, combinatorial example. With this sort of semi-decentralized situation, there's so many, just like Bitcoin itself put together all these different cryptographic techniques from the 70s through 1999 or 2001, for that paper, and then with some unique inventions in the code like the difficulty adjustment. Same thing here with Ruben. He's put together a number of amazing Bitcoin inventions together in a new configuration that's very cool. He's using L2, which we already discussed first, which is amazing. He's got adapter signatures, which is a type of scriptless script, which comes out of the anonymous Mimblewimble paper. Some of these things are actually dependent on BIPs that haven't even come through yet. So this is a still, relatively abstract protocol. It's not quite possible to use yet. And there's Lightning interoperability. So it's amazing because you have these protocols. Not only can you build stuff on top of things, but then if they're in the same layer or in a separate area, you can create interoperability situations where they're completely independent, where not one thing built on the top of another, but they just have they're separate kind of data silos that still can have interoperability. So that's amazing because they're two layer 2 protocols that can make each other better because they're different from each other and they have different trade-offs and different abilities, which is totally amazing. And especially Statechains is good for the onboarding and offboarding for Lightning channels. So it makes it even that much smoother. You don't need to have the liquidity already to open channels, things like that. It's also utilizing blind signatures. This is because you want to protect your privacy as a user. You're communicating with these state chain entities where normally they would be able to see everything. But with blind signatures, they can't see anything. So you have a situation where it's completely blind. They have no idea what you're doing. You have 100% privacy. And then over Tor, it can't be leaked either, or it's harder to leak. And then, of course, it will be, Schnorr signatures, which are aggregation signatures, and Graftroot, which is like a really complex thing that it's so hard for me to wrap my head around because it's so low level. But apparently, Statechains can also utilize that. So this is a huge long list of different inventions. That's just the main layer. Of course, each one of those depends on many amazing sort of technological primitives that built up that. But this is this amazing sort of multi-sig system where you create these incentives or disincentives to theft, and you gain of course instant transaction, highly private transactions. So that's kind of my summation there.
That's awesome stuff, man. So much technologies, guys. Sidechain, Schnorr, adapter signatures, blind signatures, L2, Graftroot. This is what we talk about. Iterative development. Over years, this type of stuff can be built. These type of technologies cannot, be built in the traditional manner where you get investment, you come up with something, you get investment, and then you go and try to build it. Like that's not quite how these technologies are going to be built. And these open source technologies continue to be built in just that free open source realm. That is where the most amount of information, in my opinion, can be transferred, in the least amount of time. So that's what we get. We get a really high signal to noise ratio in open source software. So let's go with you next on this, Jameson. So what is your comments on this so far? And I have a kind of a specific question for you, Jameson. How would you compare this to like Chaumium Cash, and is this better or worse than that?
Right. So I think an initial question is, what is the state chain actually doing? Well, in Bitcoin, there's no such thing as a Bitcoin. There are just transaction outputs. And there are transaction outputs that have been spent, and then there are transaction outputs that are unspent. And it's the unspent transaction outputs that are actually the Bitcoins. Now, when you're using state chain, you're basically entering into this 2 of 2 multi-sig smart contract. And the state chain, I forget what they called it, but basically the entity, the controller, the federation, what have you, that is on the other end of that 2 of 2 multi-sig.
Entity.
Yeah, the entity allows you to really swap ownership of your UTXO with something else, some other UTXO. It might not even be a Bitcoin UTXO. Once you add in some of the privacy features that they're saying that they're working on, then you do essentially end up with a blinded Chaumian eCash server. And Chaumian eCash is great from a privacy perspective and from a scalability perspective. The downside is that it relies upon a single server that could potentially, cease to exist, and poof, all of your money is gone. So at least with the Statechains setup, you get those privacy and scalability benefits, but you no longer have the trusted aspect of it, where if the entity ceased to exist, you still have ways to recover your funds on chain by broadcasting transactions. So I guess the real question is, like, what will this be used for? Will it be used for mixing? Will it be used for decentralized exchange? Will it be used as some sort of new entryway and like sort of on and off ramp to Lightning Network? There's definitely a number of different possibilities there, and I guess the real question will come down to incentives of will we see many of these state chain entities operating? What is the risk to the entities? What income can they make from offering these services? This is assuming that all of the underlying technology is sound, and a lot of it is still fairly theoretical. Then I think it's mostly going to come down to incentives of what are people going to benefit from operating these services and from using these services. And there's definitely plenty of potential there, but could be years before we really see these things get used in mainstream usage.
Yeah, absolutely. It's kind of funny how people still talk about mainstream, and we were just so I try to tell all the time, Jameson, I try to tell people all the time it's early days, but nobody seems to listen to me. Everybody seems to want 4K video in 1995, and it's just really, really strange. Talking about bringing this, we got to bring this to the mainstream. We have to get this to the main. We have to get this to more people. And it's like, no. I try to tell people that look, Bitcoin is going to evolve just like the internet did, at the pace that is comfortable with the internet. It's really all market based at this point, right? So if more people want more bandwidth, well, there's going to be more companies that create more ISPs and create better bandwidth. So, as Bitcoin gets bigger and bigger, the incentives will grow larger and larger, and Bitcoin will get more and more into the mainstream as the market wants it. Again, this is, for the most part, free market, based behavior here, guys. So Bitcoin is absolutely early, guys. I try to say we're around circa like 1991, maybe 92, because we're still using so many of these command line interfaces, and there's still so much more protocol development that has to still be put into the base layer here for Bitcoin to really to shine in the future as this private new money outside of the state. So I am really looking forward to shows like this and technologies like this that we've discussed on this show that come, because this shows that Bitcoin continues to iterate, continues to evolve, and is not slowing down or stopping anytime soon, guys. This is the money that the market is choosing to be that secondary choice to fiat. And this is, I don't think, again, is going to slow anytime soon. So great comments so far, guys. Patrick, last but not least, my friend, let's get you in here for this last topic. Go ahead.
Yeah, I think this is really interesting technology. As like we were mentioning earlier, this is technology is going to fill in more gaps of usability in various places for in the software that we don't maybe have yet. As Jameson mentioned, Bitcoins are like UTXOs. They're these unspent transaction outputs, and really what this is doing is allowing people to lock these UTXOs and then pass these UTXOs around to each other off chain. And then that final user can withdraw that UTXO without the permission. So there are definitely some benefits. The downsides seem to be that you have to deal in these whole UTXOs for the most part. The upsides being that you have a lot of freedom to do with those what you want to do with those UTXOs once it's in the state chain, which opens up a bunch of different use cases like this. This article basically mentions. Betting, and maybe this will have opportunities for doing decentralized like betting or Oracle-based stuff. Using colored coins maybe makes sense to have UTXOs of like a colored coin or something like that, where you're working with these very small amounts, and as long as people are dealing with it's like one unit, if it's a bunch of single units passing around, maybe that's how it will be used for some type of Xiaomi eCash functionality. There's basically CoinJoin. Essentially, it's similar to CoinJoin, where everyone kind of puts their UTXOs in, and then the mixing happens. So this is essentially could be evolved to work in a sort of CoinJoin fashion as well. So there's just a lot of unknowns, I think, how this is going to be used, but I really think it's cool technology. I'm fascinated to see like what the next use case or the first use case that comes out of this.
Yeah, it's really crazy to see. You know, every couple of years, just more of these amazing technologies for Bitcoin come out. You know, people like to say that there's not a whole lot of innovation on Bitcoin, but then you see all of these papers every single year, and it's just crazy. I'm pretty much only pay attention to Bitcoin, and this is pretty much a full-time job. So I wouldn't even have time to pay attention to anything else because so much continues to happen in Bitcoin. And guys, again, these are some of the like 3 different technologies that we talked about today, but just these 3 technologies alone enable dozens of new use case scenarios. Could possibly enable orders of magnitude scaling in the next few years. This is such important stuff, guys. And again, this is basically about the least sexy of stuff as you can get. Okay, this is not Ethereum 2.0, guys. We're not going to have unicorns up on the stage, but this is the stuff that these people are working on. Literally, I like to say all the time, Bitcoin is the Mount Everest, guys, of engineering, and it attracts the most intelligent people in the space on the planet that working on this stuff, and have been working on this stuff for many years. So thanks again, guys. I really appreciate it for joining. I think we can end it here. Let's go ahead and say goodbye to our guest, Patrick. Where can we find out more about you, sir?
Yeah, I mean, just follow me on Twitter. I think my latest handle on Twitter is probably the last one. I won't change it in the future, but at P_Miller_ on Twitter. Feel free to follow me. And yeah, I just generally tend to talk about technical topics. That's kind of why I'm on Twitter. I'm really not on Twitter so I can be social with a bunch of random people on the internet. I really am on Twitter so I can get into this signal, and because I found that's where it's really easy to hone the signal by following the right people and blocking the wrong people.
So you're one of the toxic maximalists out there. All right. Make sure you guys follow Patrick, guys. He's got a lot of great technical tweets that he does tweet out all the time. I retweet Patrick all the time, so make sure you check him out. Mr. Gabriel Devine, where can we find out more about you, sir?
You can find out more about me in Patrick's living room with his lamp there. I really like it, actually. No, I am also available on Twitter to have stupid, weird conversations. I am mostly there to talk to stupid, random people on the internet, usually about Bitcoin. And my username on Twitter is Gabriel D. Vine, letter D, V-I-N-E. And you can also send me a direct message. Once again, if you want to solicit me to shill stuff, I will be very entertained by that and reject you, but I will love it. No, but feel free to jump in and say hi. I really appreciate a few messages that I get occasionally where people say that they appreciated my commentary, and that's very encouraging to me. It makes me want to do more shows like this with Vortex, and I'd like to also say that it's been wonderful to be on with a couple of intellectual luminaries, Patrick and Jameson, so that's been an honor.
Absolutely, man. I could listen to you guys talk all day. I could listen to all 3 of you guys talk all day about Bitcoin. This is some fascinating stuff. And yeah, Gabriel, I tell you, I always bring back the DMs, the 2017 DMs, man. That was absolutely nuts. Just people offering tens of thousands of dollars to either be, on the top, what do you call it? An advisor on the top of the coin, or just to simply promote the coin. So yeah, just crazy stuff. All right, Jameson, we all know and love you, man, but let the world know, where can we find out more about you, sir?
It's Lop on Twitter, that's L-O-P-P, or lop.net, where you can find my educational resources and attempt to contact me either by expending 30 seconds of proof of work in your CPU or by sending me $100 worth of Bitcoin to show me that you mean it.
Nice, man. I got to start doing that, guys. Holy crap, Jameson. That's pretty smart. So if you want to contact Jameson, it better be a serious question. This guy doesn't have time for amateur stuff. So really awesome, Jameson. Thanks again, man, so much for being on. Really appreciate it, guys. These guys are donating their time, of course. We don't pay them or anything to get on the show. Of course, I don't get paid. This is a community supported YouTube channel. So again, guys, thanks so much. If you do enjoy content like this, please think about donating over there. Check it out, our cryptocast.network website. We would really appreciate it. So until next time, guys, keep talking Bitcoin. We'll see you later. Bye-bye.